Oh, the balloons, right? The most sickening ride in the park. This thing here, one of the things you could do on this is you could look at the spin of one of those things there, right? And you ought to be able to get a centripetal acceleration, right? And the centripetal acceleration should be 4 pi squared r over t squared, right? The radius of this, I think you're going to have to estimate that. The question is, do we have a good radius for this? For the balloons. See, we don't really have a measurement in there. I do think, though, that the length of these fences is pretty standard, right? And so I know around the spider, we know that that distance there is 2.04 meters, right? So if we go in here for the balloons, you can say, okay, that's 2.04 meters. Okay. We also have data in here. So if you look at this, I'm doing a control click, save link as, and then I'm going to save it in there. And then if I just open that, if you look, here is the centripetal acceleration. Now, why it goes up and down like that is a mystery to me. But if we look at this, if we can zoom in on this, let's see, I think a control click, zoom graph in, there we go. You can see that the acceleration is about 4 meters per second squared at its max, or maybe 5. Okay, so let's go back here, right? Your acceleration should be 4 pi squared r over t squared. You ought to be able to get the measurement of this, what the radius is, or estimate that, right? You ought to be able to get the period. Either you timed it yourself, or you can look at the video and just see somebody going crazy, right? And click on them at the beginning of a rotation and then at the end and subtract the times, right? So that would give you the period there. And then you could compare 3 things. One is what your handheld accelerometer was, what you're reading, right? What the calculation was, 2, right? That equals something, right? And then 3, you could also talk about what the data, right? Data from the lab quest. Okay, other than that, I mean, just it's a sickening ride. It goes up and down. You could figure out the amount of work done to lift this thing, MGH, right? You could divide that by the time and figure out the power that the thing has to do to lift that entire ride up like that. Yeah, I can't think of anything else, but I'm sure there are other things to do.